So in Lesson 7, we're going to apply some of the information we learned about in our lecture video as well as our reading. So the first thing you need to know is it's probably going to be helpful to have a periodic table nearby. There's one in this lecture handout, so if you need another one, go ahead, one that has names of the elements, go ahead and get a separate one pulled up. So using the periodic table, give the name and the symbol for each of the following elements. So the information we're given will help us identify the halogen in the same period, which really means row, as an alkyl metal with 11 protons. So there's a couple of things. One, if it's got 11 protons, we're looking for element number 11, and we're looking for an alkali metal. So that's sodium, and we're looking for the halogen that's in that same row. So we're going to go all the way across. And the halogens are in group 7A, so that's going to make chlorine, our element we're looking for. The second one says the alkaline earth metal, so this is group 2A. In the same period, so row, with the neutral noble gas with 18 electrons. So that's important because this tells us that if it's neutral, it's also going to have 18 protons, which means it's element number 18. And so we're going to start off with argon, and we're looking for the alkaline earth metal, which is group 2A. And so that would be magnesium, Mg. The noble gas in the same row, so 8A, as an isotope with 30 neutrons and 25 protons. So we're looking for the element that has 25 protons, and that's going to be manganese, and we're looking for the noble gas, which is krypton, Kr. Now you're going to practice this one. So in ionic compounds, they're formed when two or more atoms transfer electrons. So who tends to lose the electrons? These were our metals. What forms when the electrons are lost? Well, they lose something negative, so they're going to become overall positively charged. And I always remember the T in cation as being the positive. Who gains the electrons? These are our nonmetals. And what forms when the electrons are gained? An anion. And I always remember the N in anion for negative. Why would it make sense that covalent bonds are associated with a sharing of electrons between two atoms that are located in close proximity to each other? Well, the rule is for a variety of reasons, but one of the ways is because they have similar chemical and physical properties. So they're going to tend to want to share rather than transfer. Now here is a list of polyatomic ions from your book. These are ones you need to know, and they're given here, and you'll see that there's going to be a quiz over this material. And you'll know which quiz it is because it'll tell you that this topic is over polyatomic ions. So for each of the following compounds, state whether it's ionic, covalent, and if it's ionic, write the symbols for the ions involved. So one of the things we need to specify is that ionic can be a metal and a nonmetal, a metal and a polyatomic and a nonmetal, or it can be two polyatomics together, whereas a covalent is going to be a nonmetal plus a nonmetal. So we may not have committed all the polyatomics to our memory yet, which is why having this table here is helpful. But for the most part, when we're looking at these first two, these are binary. It's only going to be two element types. If we see more than two types of elements in our formula, it means that one of them is a polyatomic group. So we're going to have KClO4. ClO4 is a polyatomic group, so it's going to be ionic. The ions are going to be potassium, which is in group 1A, so it wants to be a 1+ charge. and perchlorate, which is a 1 minus charge. It's given here on this chart. The next one is magnesium with this group right here. This is also going to be ionic. Now magnesium is in the group 2A column, giving it a 2 plus charge. However, this 2 right here really is the charge on the magnesium. The charge on the polyatomic group is going to be 1 minus. It is right here on the table. It's just a different rearrangement. So this is C2H3O2 as well. The next one is H2S. So hydrogen's a little bit of an anomaly because it's on the periodic table on the left as a metal, but on some periodic tables it's going to be on the right-hand side with helium. And so hydrogen is technically going to be classified as a non-metal in this case, which makes this a covalent compound because sulfur is also a non-metal. Ag2S is going to be ionic because silver is a metal. It's a transition metal, and sulfur is a non-metal. As far as their charges go, sulfur is in group 6A, meaning it likes to have a 2 minus charge. But it's also, the number right here is the subscript on sulfur. And silver is going to be a 1 plus because the same reason, this is a 1 behind the sulfur, and that becomes the charge on the silver. The next question is N2Cl4. Nitrogen and chlorine are both nonmetals, making this covalent. The last one is cobalt nitrate. Nitrate is a polyatomic group, so it's going to be ionic. The 2 subscript behind the NO3 group is also the positive charge on the cobalt. And if we look at our table, nitrate is going to have an NO3 1 minus charge. So one of the things that we haven't covered yet is how to predict what compounds are going to form from ionic compounds. So I'm going to show you my trick here so that hopefully this will help you. So I'm going to write them out, and I'm going to do different colors. Okay, so when potassium and oxide come together, what is going to happen is the charge on the oxygen is going to become the subscript behind the potassium, and the charge on the potassium is going to become the subscript behind the oxygen. They are going to swap charges, and they're also going to take the absolute value. And the reason why is because if oxygen is a 2 minus charge, and it is, 1 potassium is not enough to counteract that charge. It's going to take 2 potassiums, and a 1 and a 1 equals 2 if we add them together, which means they are going to balance each other out. So it's going to be 2 potassiums for every 1 oxygen. We do the same thing for ammonium and phosphate. These are 2 polyatomic groups. I'm going to use parentheses to protect my polyatomic groups so that they are grouped together. If I didn't use parentheses and I just swapped the charges, took the 3 and then the 1, that would look like, and we know that that's not the same thing as what we just said off to the left. So when we look at what this breaks down to, the phosphate group has a 3 minus charge, and the ammonium group only has a 1 plus charge. So it's going to take 3 of the positively charged ammonium groups to cancel out the negative charge on the phosphate group. So now this element right here should be Al3+. So when I take the 3 and the 2, I'm going to swap their charges and take the absolute value. The 2 behind the oxygen becomes a subscript on the aluminum, and the same thing for the oxygen. And then let's see why. So if I have aluminum 3+, and I have 2 of them, the total charge here is 6+. If I do the same thing with oxygen, and I take 3 of them, that's 6-. And that's the type of charge balance that we need to form a compound. So you're going to practice these last two right here and predict what ionic compound will form when they combine.